Welcome to The Explainer. You know, sometimes in manufacturing, the best solution isn't one single process, but a perfect team-up. Today, we're looking at a classic partnership, one that takes molten metal and turns it into parts that are both incredibly complex and unbelievably precise. So, let's just jump right into a classic problem that engineers and designers wrestle with all the time. Imagine you need a part with a really complicated shape on the inside, but it also has to fit perfectly with another piece. I mean, we're talking about a perfect seal. How do you get both of those things, that complex shape and that perfect fit, in one part? And here's the kicker, without it costing a fortune.
Right. And that is the heart of the manufacturing puzzle we're talking about today. It's this constant battle between complexity and accuracy. You know, you need those wild internal pathways for, say, a valve body, but you also need that razor-sharp precision for the threads and the surfaces that have to seal perfectly. If you mess up either one, the whole thing is useless.
So how do we solve this? Well, the key lies in two very different processes. You can think of one as an ancient art of shaping metal and the other as a totally modern science of finishing it. Let's meet our two main players in this story, because on their own, they're good, but together, they're amazing. All right, first up to bat is brass casting. Now, this process is all about the big picture. It's the artist that creates the fundamental foundational shape of the part. This is where that complex idea starts to become a physical reality. So what is casting, really? At its most basic, you're just turning liquid metal into a solid object. That's it. You melt down brass, pour it into a mold, which could be made of sand or wax or something else, and then you let it cool. As it solidifies, it takes on the shape of that mold. The result is what we call a near-net shape part, which is just a fancy way of saying it's almost the final shape you want.
And this is where we see the big trade-off with casting. Its greatest strength is also its biggest weakness. It's like a brilliant sculptor who can create these amazing, flowing shapes and complex internal details that would be a nightmare to carve out. It gets the big idea, the overall form, perfectly. But there's a catch. As that molten brass cools and turns solid, it shrinks a little. And that shrinkage means the dimensions aren't exact, and the surface finish is kind of rough. So great for the general shape, not so great for the fine details.
Okay, so if casting is our artist, our sculptor, our second player, machining, is the scientist. It takes a completely different approach. If casting is all about forming the shape, machining is 100% about refining it.
Yeah, see, unlike casting where you're adding liquid metal to a mold, machining is a subtractive process. You start with a piece of material and you take bits away. It's less like a sculptor and more like a precision surgeon using super sharp tools to carefully carve away tiny slivers of metal. This is how you get that incredible hair's breadth accuracy.
And here is the other side of that coin. Machining is fantastic for precision. You know, modern computer-controlled or CNC machines can hit insane tolerances. But just imagine for a second trying to create that complex valve we talked about with all its internal channels by starting with a solid block of brass. It would take forever, and you'd end up with a tiny part and a giant pile of expensive brass shavings. It's just not efficient for creating the initial shape.
So what kind of precision are we talking about? Well, machining brings a level of control that casting just can't even dream of. We are talking about tolerances of plus or minus 0.05 of a millimeter. I mean, that's thinner than a human hair. And on critical surfaces, that's the difference between a perfect, leak-proof seal and a complete failure.
Okay, so this is the moment. This is where our two characters, the artist and the scientist, stop being competitors and become the perfect team. It's not about choosing casting or machining. It's about using them together in a smart workflow that plays to both of their strengths.
And here's how that workflow looks. It's actually super logical when you think about it. Step 1, you let casting do all the heavy lifting. Get that complex, near-net shape made quickly and cheaply. Then, you do a quick check, maybe with an X-ray, to make sure there are no hidden bubbles or cracks inside. And then, you bring in the CNC machine. But you're not carving the whole thing. You're just machining the critical bits, the surfaces that need to be perfectly flat, the holes that need to be perfectly round, the threads that have to be just right.
Right, the whole point of that first casting step is, like this quote says, to get that near-net shape done quickly and economically. Let's go back to that brass valve you might have under your sink. Casting is pretty much the only way to create those complex internal channels for water to flow through without spending a ton of money.
But then comes the magic touch. Once you have that raw cast shape, the CNC machine comes in to finish the job. It's going to precisely cut the threads for the pipes to screw into, and it's going to mill the surfaces perfectly flat where a gasket or a seal needs to sit. This is what guarantees a leak-proof fit. It's what makes the part reliable for years and years.
So, okay, that's the process. But why should you care? Whether you're an engineer, a product designer, or honestly, even just someone who's curious about how stuff is made, what's the real benefit of this partnership? Why is this the winning strategy?
Well, the payoff is massive. First, it's way more cost-effective. You're not wasting a bunch of expensive material, and you spend way less time on the machine. Second, it gives designers incredible freedom to create complex parts that are also precise. And finally, you just get a better part. You get the structural integrity from the casting and the high-tolerance fit from the machining. It is, literally, the best of both worlds.
And because it works so well, you see this exact strategy being used all over the place. Think about marine environments. For something like a boat propeller, you need a very complex shape, and it has to be made from a material that won't corrode in salt water, perfect for brass casting and machining. Or think about the plumbing fittings in your house. You need millions of them, they have to be cheap, and they can't leak. Again, this partnership is the perfect answer.
So, at the end of the day, this amazing team-up of casting and machining is a perfect example of a bigger idea. That by smartly combining different processes, you can get a result that's way better than what any single process could achieve on its own. It really is a case of the whole being greater than the sum of its parts, which, kind of makes you wonder. With all the new technologies coming out, like advanced 3D printing or AI-driven design, what's the next perfect partnership in manufacturing going to look like?